The question says write the IUPAC name for the following complex. This is the complex given here, and it is a dinuclear complex because you can see in this complex two central metal atoms are present. Okay, to name the complex we follow the order. First we write ligand, and then we have central metal atom, and then we have oxidation number of the central metal atom in Roman numbers. Okay, next part. We identify if the central metal atom is present in the cationic complex or in anionic complex. Keep in mind, if the central metal atom is present in the cationic complex, we use its common name as given in the periodic table. And if the central metal atom is present in anionic complex, we use its special name. Okay, for example, now you can see this is one part of the complex and this is another part of the complex. If I break it from here, first one is positive, second one is what? Negative. Okay, so you can see chromium is present in the cationic complex and cobalt is present in the anionic complex. In this case, chromium naming, I will use the common name chromium, but in this case cobalt is present in anionic complex, then I will use the special name for the cobalt. It will be cobaltate. Okay, next part. We calculate the oxidation number. We need oxidation number of the central metal atom. Okay, you can see we have chromium, it is NH3 is there, NH3 whole 6 is there. If you calculate oxidation number of chromium, this is Cr, it is a neutral ligand, ammonia. So we can say 6 multiplied by 0 is equal to 0. So chromium is present in 0 oxidation number, roughly we are calculating. Now next part we have cobalt, and this is what unidentate and negative ligand is there, whole 6 is there. If you calculate oxidation number of cobalt, unidentate negative ligand means Cn will show -1 charge. We have plus 6, it is what? -1 is equal to 0. I take it as a neutral. Cobalt is equal to plus 6 we got. Okay, this is not the common oxidation number of cobalt. Okay, plus 6 is very high oxidation number. So we do one thing, we equally distribute the oxidation number. I take it plus 3 oxidation number of cobalt, dinuclear complex is there. So plus 3 I consider for this cobalt and plus 3 I consider for the chromium. Okay, so the overall oxidation number will be plus 6, plus 3 and plus 3 here also. When cobalt is present, see, we have to maintain the neutrality of the complex. If cobalt is present in plus 3 and this cyanide ion is present in -6, so plus 3 minus 6 is equal to -3. Overall charge of this part will be what? -3. Overall charge of this part will be plus 3. Plus 3 minus 3 is equal to 0. That's why it is a neutral complex. Very interesting part. Okay, so plus 3 is the oxidation number of cobalt and plus 3 is the oxidation number of chromium. We equally distribute. Now we can say cobalt is showing its common oxidation number. Okay, if you want to see how this complex is neutral, because overall for this entire part is -3, for this entire part is plus 3. Okay, now we can do the naming. Okay, so we follow the other. First of all ligand, then central metal atom, and then we have oxidation number. Need some more space. Okay, now first cationic part followed by anionic part. This is how we do the naming. Ligand, how many ligands are there? 6. What kind of ligand? Ammonia molecule is there. So in this case we can say, we can use prefix, hexa. Hexa is there. For 6 we can use hexa. And then this is what? Amine. Keep in mind there should be double M, amine, hexamine, and we use the common name for the chromium because it is present in the cationic complex. Hexamine chromium. Chromium is there. Oxidation number 3. Then after that we move on to the anionic complex. Again we have ligand. What kind of ligand? Cyanide ion. So we name it as a cyanido. But 6 are there, so we can mention hexacyanido. Hexacyanido. Okay. Then we move on to the central metal atom, that is cobalt. We have to use a special name because it is present in the anionic complex. We use cobaltate. Cobaltate is there. What is the oxidation number? It is 3 is there. Again, it is a neutral complex. We don't need to add ion. Okay. So name of this complex is what? Hexaamine chromium 3 hexacyanidocobaltate 3. That is the name, IUPAC name of this complex. If you like this video, please share and subscribe to the channel.